Hello and welcome to a new Python tutorial. Over the last 60 episodes, we've looked at many functions and code structures, some of which can be used in place of others to help with code efficiency or ease of use. So, to help substantiate some of those claims, we are going to learn today how to measure the speed of our code. We will look at two distinct methods of doing this. The first, which we'll see today, involves the timeit module. We can start importing the module by writing import timeit as ti. Now let's write a simple function that calculates the square of a list of numbers. So let's write def funct, short for function, of n, and then res equals empty list, and then for I in range 1 to n plus 1, res dot append I squared, and finally return res. Now we can call the function by saying funct of, let's say, 1000. Now we need to build a code to measure the speed of our function. Luckily, the timeit module has a built-in function which allows us to do precisely that. We can call the function by saying print ti.timeit. In this case, the function has the same name as the module. And then we can say stmt equals our code and number equals, let's say, 10,000. We also need to modify our code above by saying, in this case, our code equals 3 open speech marks and then 3 closed speech marks at the end of our code. Now what the timeit function will do is it will take our code and run it 10,000 times and give us the total runtime. Of course, if we want the individual runtime, then all we have to do is divide the total runtime by the number of runs. In this case, we'll leave it as the total runtime. As always, we can run the code using the F5 key, and on the right-hand side, we get that the total runtime is approximately 3.7 seconds. Now let's return to the left-hand side and modify our function to use numpy arrays. We can write at the top our setup, and that will be again equal to 3 open speech marks, and we can say import numpy as np, and then close the 3 speech marks. Then we have our code, which in this case we will have to modify to use the numpy module. We can simply write return np.arange from 1 to n plus 1, all of that squared. Now for those of you who would like to go through a quick review of the numpy module and of how some of its key functions work, I'll leave a link in the top right hand corner of your screen to my tutorial on the numpy module. Returning to our code, in line 17 we have to also add that setup equals our setup. So in this case, we've added an extra variable to our timeit function called setup. What the function will now do is run our setup to start with, and then run our code 10,000 times. Also consider that the total runtime calculated by the timeit function does not include the time required for our setup. So in this case, we are only measuring the time required by our function. If we run the code again, pressing the F5 key, we get that the numpy version of our function is approximately 100 times faster than our list iteration. So now you can see why I recommend using numpy arrays anytime large calculations are required. Having said that, next week we'll look at another way of measuring the speed of our code, But until then, don't forget to check out my other tutorials and coding challenges. Thank you all for the support you provide by watching these tutorials, leaving comments below, and subscribing to the channel. It really means a lot. As always, I look forward to seeing you all next week for another exciting video. And until then, happy coding!